Research methods, key terminology and issues. There are many ways in which research is said to be. It is thought of as reading around the topic and also the collection and analysis of data. The definition is a process of trying to discover something that advances understanding, knowledge and skills that is guided by seeking answers to questions and working out problems. Research has been crucial in sport, especially when it comes to the technology that has been installed. For a change to happen, there will have to be research done so a change can be put in place effectively. Technology has improved a lot in sport. It has improved in performance, led to a faster rate recovery to injuries, and has also helped refs with making crucial decisions. Examples of this include TMO in rugby and more recently goal line technology in football. Qualitative research. This research uses words instead of a numeric approach. It is generally subjective as it looks at a person's opinion, emotions and feelings towards a topic matter. Qualitative data can be turned into quantitative data from the answers to the questions. On the screen there is an example of this. A question like, what is your favourite sport and why? With the first half of the question having the capability to be turned to quantitative data. This data is explained on the next slide. Finally, qualitative data is there to be analysed and create explanations, models and theories for the results, as it explains differences, causality or links. Quantitative research. This was mentioned on the previous slide. This is a subjective piece of research method where numbers and statistics are obtained from the inquiry. When trying to analyse the measurements and statistics, it is critical that the accuracy of the data collection is very good. On the slide there is an example of quantitative research question. For a gym workout plan, the question could be asked how many of a certain group has reached their goals that's set before the workout plan. This can be conducted in large sample sizes, which is crucial as it helps improve accuracy and smooths out any false readings. Here are the 5 key issues that can affect research. Reliability is the repeatability and consistency of a test and the results. Internal validity, nothing that can be controlled has affected the study. External validity, whether the study can be generalized and applied to other people or situations. Accuracy, how close your measurement is to what you are intending to measure. And then finally, precision is how small differences that measurement devices can detect. For M1 and D1, I've given a sporting example which helps it portray the issues that are with research. The example that I've given is the effects of creatine on sprinting performance. This has been in the test. It does the pre-test, and then the candidates will train for 4 weeks with creatine. Then after that, it will be the post-test. These tests will be a 30-meter sprint. Overall, in the test, there was improvement in sprint time after 4 weeks of creatine. Creatine is a substance that is found naturally in muscle cells. It helps your muscles produce energy during high intensive exercise. Despite the result, we must see if the results can be believed. Reliability. Reliability. If you carried out the research again, you would get the same or similar results. This shows that that something is reliable. There are three types of reliability: inter-researcher reliability, test-retest reliability, measurement error. Inter-researcher reliability is the difference in results due to the researchers changing methods. This could be down to a different person taking out the experiment. Test-retest reliability. To be reliable, the test itself must yield consistent data. Going back to the test, the change in results, if any, must be down to the creatine and nothing else. This is for both the pre-test and the post-test. Measurement error. This means whether the items in the investigation measures what it's trying to measure correctly. In this example, it could be whether a stopwatch or light gates were used, with light gates obviously being a lot more accurate than a stopwatch, which brings in human error. If all of these issues are at a minimum and the test was done in the right way, it proves that the study was very reliable. External validity. If the people who are being researched improve under creatine, does that mean everyone around the world will improve as well? A definition could be whether the for external validity is whether the findings can align with the real world. To get good external validity, the sampling has to be a good match to the population, which takes into consideration ethnicities, ages and heights. This is improved by stratified sampling. This is a way of bringing in an equal amount of people for certain categories, such as age and gender. The more samples in an investigation, the better. Other threats to external validity are if your study doesn't relate to the real world. In this test, if you get a professional football team doing the test over the 4 weeks, it wouldn't relate to the real world as they are athletes. However, if the study was aimed at professional athletes, their external validity would increase. Another factor that affects external validity would be the setting in which the test was done. If it was done inside, the test would be less externally reliable, as if compared to if the test was done on a proper track. If you can find the external validity of your experiment, you can be critical of both your research as well as past pieces of work. If your study is relevant to the real world, it would have a high external validity, whereas if it didn't, it would have a low external validity. Internal validity. This refers to how well an experiment is done. Is the sprint performance improvement purely down to the creatine, or was there anything else that could have added to the result? Intervening factors are things that would change the scenario from the pre-test to the post-test. These could include how much sleep someone would get, how much fatigue from training that they have, the supplements that they could take in, such as caffeine, and also the weather that they contain, that they have on the 2 test days. The intervening factors for the 4 weeks in between the tests are not doing enough training, getting injured, not taking enough creatine so it doesn't have enough impact. A good example of an intervening factor is the placebo effect, which is a psychological trick into making them believe that improvements will be made even though a placebo has nothing in it to improve performance. In this case, the creatine might not really improve performance, but because participants lead to believe it does, it may not give results that say otherwise. So if the creatine has the same effect as a placebo pill, it would indicate that it hasn't done much for their sprinting. So the question has to be asked, did some people get quicker because they thought they would? So a way of testing this would be to have two groups, one taking placebo pill and the other the creatine, and then analyse the difference between the two groups. Another intervening factor is the learning effect. The more you conduct the test, the better people get at it. And in this case, it could be their reaction time could improve from doing it over again, as the anticipation will heighten. This would improve their time with a quicker start time. This is not good for the test, as the times would improve, but that's not necessarily down to the creatine. A way of preventing this is a control group, an extra group of subjects who just do the pre and post test to see if there is a chance of the learning effect. If test scores improve in the learning group, there is a learning effect, as well as a habituation test where you let subjects practice the test enough before the pre-test. If a study can control or prevent intervening variables, it has a high internal validity. If this isn't the case, the study would be classed as having a low internal validity. Accuracy and precision. Accuracy is how close a measurement is to what you are trying to measure. In this case, if someone ran 30 meters in 4.29 seconds, and the timer said it was 4.3 seconds, you would say it was quite accurate. However, if the time said 4.53, for example, then the result wouldn't be as accurate. A way of improving accuracy in this test would be just having light gates. Precision. This is again how fine or small a difference a measuring device can detect. The degree of unpredictability relate to the amount of precision the tool selected has. In this case, if the stopwatch rounds to the nearest 1 decimal point, then it is not as precise as a stopwatch that rounds to 2 decimal points. You have to ask yourself, how does accuracy or / precision affect validity and reliability if you don't follow the right method, like the sprint being 35 meters instead of 30 meters, for example? It is likely the data collected will be less accurate and precise. If this is true, the test would not measure what it is trying to measure and would become far less valid. Furthermore, if the data isn't accurate or of precise, there will be varying results, differing degrees in errors that are made. In this case, the results of whether creatine makes a difference reduces the reliability. A final issue to do with research is objectivity. This means in some contexts being fair or open to all sides of an argument. Primary data and secondary data. Primary data, this type of collection collects new and original data which is specific to a project. An example would be whether doing a warm-up affects how quick you cycle in track cycling. You could do this back-to-back days, with one day with a warm-up and one day without. Ways to also obtain primary data is through interviews, questionnaires, and focus groups. Secondary data, this uses already published research which can be found in journals, websites, books, and other forms of social media. Secondary research is used to make rationales to support your work or counter-argue somebody else's. Classifications of data. Discrete data is a form of data where only separate, isolated, or opposite values can be achieved. An example of this would be a yes or no question. Nominal data. A nominal scale is where participants are put into categories and counted. An example of this would be separating football players into their own teams. Ordinal data is ranked data that gives no indication of the difference between levels. It would also, it allows you in fact to say who is the best, but doesn't say by how much.